Hello and welcome to item 9 of the first chapter of Effective Java, which is about try with resources. And in the previous item, we said that don't use finalizers or cleaners for resource management. And then the question was, okay, if we shouldn't use finalizers, then what is the alternative, right? What solution the JDK or Java language provides us? And they are providing us with this construct of try with resources. Now, try, catch, finally block was with Java from the early on, but then try with resources was introduced, I believe, from JDK 5, if I'm not mistaken. And the concept is that there are some classes that can throw exceptions, and then usually those classes also deal with resources. Maybe file handling or anything, any native resource that the JVM has to acquire from the operating system for a particular object. And then when that object is no longer in the scope and there is no reference or pointer on the stack, on the Java stack, that points or refers to that object, it means that object is abandoned, is garbage. And then what we want is that when that goes out of the scope, we want to be able to deterministically release that native resource that this object holds on to. And we said that the main problem with finalizers and cleaners is that the task of running those is on the shoulders of the GC, garbage collector, and there is no guarantee that when GC is going to be run. It might never run. Therefore, resource cleanup using the GC garbage collection is a bad idea, or is not the best idea. So item 9 directly states that prefer try with resources to try finally, and there are a couple of reasons for this. And before really looking at the try construct, and let's see what the try construct or basically let's step back and look at the C++ language, which is a precursor to the Java language. So in C++ language, specifications demand the destructor of an object be called when the object is destroyed. So C++ language demands a deterministic destruction of objects. So if I create a point class in C++, I have to call the constructor. But then the C++ language also provides another construct or another special method called point with a tilde sign before that, and this is called the destructor. And this destructor will be called, this is guaranteed, will be called when that object goes out of the scope. And obviously when we're dealing with objects in C++, the question is where is the memory for holding this object is allocated. And C++ allows the developer to either allocate on the stack or on the heap, right? Anything on the stack, if you're familiar with the stack data structure, you know that it's just a pointer that moves up and down the stack, right? Up and down the memory block that is allocated for the stack. And I believe in Linux systems, a stack is about 2 megabytes or so. It depends on the computer, the operating system, etc. But it's usually very limited space, right? So in C++, objects created on the stack will be automatically destroyed. So the object management or memory management for when the objects are destroyed is automatic, because program counter just moves up and down the stack, right? It's an automatic thing. That's why this is nice, because then when we allocate on the stack, we don't need to worry about calling the destructor. This will be definitely called. But then the problem is that we cannot return a reference or a pointer to an object that is allocated on the stack inside another method or function, because as soon as that the scope of that function ends, that object is destroyed because it was allocated on the stack, and we no longer have a valid handle to that object. And that's the problem, and that's why the solution is to allocate on the heap, and then as long as there is a reference to that or the pointer to that object on the heap, that object is going to be alive on the heap, right? Same idea with the Java. In Java, you always allocate on the Java heap. There is no notion of developers cannot basically allocate on the stack. A stack is fully managed by the JVM, etc. So objects created on the stack will be automatically destroyed at the end of the scope. And because we know that it's a deterministic destruction, we can actually put code that manage the release of the resources in the destructor, because we know exactly when that object is destroyed. And obviously Java doesn't allow creating objects on the stack, so this is this is not given. And then even if we allocate on a Java heap, we don't know when the object is going to be destroyed and claimed by the garbage collector. So it looks like Java doesn't provide a deterministic way of releasing the resources, and then the try with resources comes to rescue, right? So objects gone out of the scope are subject to garbage collection. We know that, but the problem is that we don't know when it's going to run. Do not mix up memory management with resource management. Again, I put an emphasis on this point also in the previous lecture about item 8. GC is great. Automatic memory management for Java was really great, was really enticing and attractive, but then resource management is not the same as memory management. Because resource management, there's always JVM can only ask for a finite amount of resources from the operating system, just because otherwise the rest of the system might collapse or crash or be starved, etc., right? But memory, in these days, it's not an issue. If a system has like a 32 gigabyte of RAM, JVM can easily ask for half of it, and the operating system is probably happy to hand over half of the available RAM, available memory to JVM, right? But then resources is not the same. JVM resources are managed automatically. When we say resources, for example, if you use any of the core JDK libraries like file streams, etc., these are already implemented in the back end of JVM, so that they automatically know how to manage it. But sometimes you have to, as a developer, you're writing a library to talk to a USB port, GPIB port, etc. You have to do some sort of hardware access, and in order to do hardware access, you have to go through the operating system, doing system or kernel calls, which means you have to ask the operating system to give you some native resources, right? So native or OS resources typically have to be managed manually, and the problem is that everything in Java is classes, right? Which means what we want to have some sort of similar concept to RAII. Resource acquisition is initialization. This is a very well-known terminology in C++. If you're not familiar what RAII is, you can just Google it. And the idea is that when you create a class, in the constructor of that class, you acquire that resource and initialize it. And then when the class goes out of the scope, which means the object is no longer used, the destructor is going to clean up whatever resources we had, and it's going to release them. And obviously the problem in Java is not the constructor, it's exactly the same. The main problem in Java, in contrary to C++, is non-deterministic destruction of the objects. In Java, we don't know when the object is going to be destroyed by the garbage collection, right? The Java libraries include many resources that must be closed manually by invoking a close method. And again, even before introducing try with resources, the JDK developers came up with these marker interfaces, like I believe we have the Autocloseable. This is one of the marker interfaces, and this is typically used for custom resources, the resources that are acquired by the user or a particular Java library which is not part of the core JDK. But then for the stream classes, for example, file input stream or any type of input stream or output stream, we have closable interface, which extends the autocloseable. But closable is a marker interface specifically used for the streams in Java. Autocloseable is more general, but closable is specifically used for basically stream classes. So if I head to Eclipse, let's look at input stream from Java IO, and implements closable, right? So the closable is an interface that has one method, public void close. And again, as you can see, the resource management is from finalizers and cleaners. We're going to, because in order to have a deterministic destruction, we have to give a hint to the user of our code that this class has some capabilities for closing the resources. So if you see a class that implements autocloseable interface, which means this class can acquire, if this class acquires some native resources, you can call close, you have to call it close. So it's a strong indication that this class deals with native resources. And as you can see, this closable is specifically used for the streams, right? Closes this stream and releases any system resources associated with it. If the stream is already closed, then invoking this method has no effect. Now they declared this close with throws IO exception because even closing a resource basically can throw exception. If something happens, operating system freezes, there's a hard disk failure, I don't know. Well, it's a very rare case that you cannot close a resource if you have successfully acquired it. Now this closable extends autocloseable, and autocloseable is a generic closable interface. And as you can see, Josh Block wrote this. This is from JDK 1.7 when they introduced the concept of try with resources. And autocloseable has one method, obviously close, and closes this resource, relinquishing any underlying resource. This method is invoked automatically on objects managed by the try with resources and statement. So try with resources came to the rescue in terms of automatic or deterministic resource management, right? And the close will be automatically called, and the responsibility of the developer is to make sure that the class implements this interface, and then you put the cleanup in the close method, right? So that's the idea. Now what I want to do is let's create a new package here, package item 9, and let's create a class, resource class, for example. And what we're going to do, let's say we have some a string, something resource, a native resource, for example, or let's say object, this is our resource, and then we have a public constructor resource class, and then here we somehow initialize this to something. So new object, so I'm going to create a just and assume that we initialize the resource, assume that we initialize the resource, right? So in the constructor we initialize the resource. This is again RAII, which is resource acquisition. Resource acquisition is initialization, RAII, which means as soon as you create the class, it acquires the resource, and then there has to be a destructor somewhere, destructor to clean up and basically relinquish the acquisition of that resource. But unfortunately we don't have that in Java. So what we do, we implement autocloseable. Note that we don't implement closable, we implement autocloseable. Closable doesn't really work with try with resources, right? So, and it's mainly used for the JDK stream classes, but here we just implement autocloseable, and then we basically use the close method as the destructor, the thing that has to happen in the destructor, which we don't have destructor. So we just we just use this close method, and I'm going to comment out this exception because otherwise we kind of need to handle it, and then closing resource, right, in close method. So that's it. That's how we do RAII in Java using autocloseable. And then what happens here is that if I go to if I create a test class, let's have a main, and then let's have a test1 method, which is a static method, public static void test1. Now if I say resource class RC is new resource class, and then if I run this, the close method is not, even though the scope, this is a local variable to this scope of this method, and when we come back from this method call, we are here, RC is out of the scope, and is basically eligible for garbage collection, right? However, this doesn't mean that the close method is going to be automatically called, so that doesn't happen. So how do we do some sort of pseudo automatic resource management? Basically what we do here is that we know that we're not returning a reference. This resource class is local to this method. So what we do, we put its creation inside the try with resources. So try with resources construct. All right, so try, and this try actually now has an argument, and we put the creation of the object that manages a native resource right inside this try argument, right? And you can have as many statements as you need, as you want. You can have it's like you can put any Java statement here and separate them with semicolon. There is no problem. And as you can put as many objects that create resources here, and then the scope of those objects is the scope of the try construct. And then as soon as you hit the end of the scope of the try, so at the end of try scope, we know that the Java guarantees that the close will be called if this object implements autocloseable. So if I run this, as you can see, the close method was called. So it was too late to kind of go or implement the same concept as destructors in C++, right? So they came up with this marker which has a close method, right? And then they modified the try construct so that so the try already existed, so they just added a new variant to it. And then this try with resources construct provides the 100% guarantee that the close will be called. So what happens if we don't implement the autocloseable? Now obviously this is not an override anymore, but this is still a valid code. We have a close that anybody can call and do cleanups, but there is no relation to our class and autocloseable. And as you can see now, try with resources basically complains that the resource type resource class does not implement Java lang autocloseable, right? So what this says is that the classes that go inside the argument of try with resources, they have to be managing some resources, and they have to be marked with the autocloseable interface. Otherwise the Java compiler complains and doesn't allow your Java code to be compiled, right? So this is a compilation error. This is a runtime. This is not a runtime error. What about we know that the closable basically so if I save this, the complaint goes away, right? This is valid. We know that the closable extends autocloseable. So what about this? So the idea here is that if we go back to the closable type, as you can see, basically we kind of need to import it here from Java IO, and this still works fine. We are overriding the close, and this resource class, this seems to work fine and compile, and it still works. So using closable and autocloseable, they both work, but closable is mainly reserved for the stream classes for the JDK itself. Therefore it's better to just use autocloseable. And as you can see, closable is in the Java IO. That's why it's another indicator that closable is mainly for the IO classes or stream classes. But autocloseable is part of the core API, part of the Java lang. That's why you don't need to really import it, right? So definitely use autocloseable. It's a override of the close. We do our cleanup here, and we put our class in try with resources. Now what happens if you want to actually create this RC class, but then you want to return it, right? Let's say you want to return a reference, or maybe instead of modifying this, I'm going to create a new method. So first of all, at the end of the try scope, the close will be called, and then the scope of this RC variable is limited to the scope of the try. So if I try to say RC dot whatever, you see it's not recognized. And if we see the RC cannot be resolved, which means RC is not recognized outside this block, although inside this block it's recognized, right? But outside the try block is not recognized. And basically what happens in the class file is just that the compiler automatically adds a finally block and calls the close. That's the equivalent. This is some automatic stuff that happens in the class file. But you okay, and then now let's assume in the test 2 we want to create the resource in a method, right? And then we want to return it. So in test 2 we're going to create our resource and return it. Obviously in order to return it, you have to be able to access it so that you cannot really use it with try with resources here. So I'm going to return RC, and then we're going to change the type to here. So let's say resource class RC is test2, right? So this static method creates our resource object and returns the reference to it. Obviously if I call this, the close is not going to be called, so we still have a resource leak, or the resource is never returned back to the OS. So what do we do in this case? So we're not directly calling the new, we don't do this. Instead, let's see if we can use try with resources. So try resources RC is test2, and this seems to compile fine. So this class, note that we're not calling the new on the class, but there is a method that calls the new and returns a reference to it. So let's see, the close is called. So it's not just about immediately constructing the object inside this try argument. You can create the object somewhere else and then return a reference to it. And then again, the scope of this reference is still the scope of the try, but because Java looks at the type resource class and knows that it implements autocloseable, so it knows that when we're using try with resources, it has to call the close method on it, right? So the key here is that now this works. What about basically we create the resource outside and then try to call the try on this? Does this work? And the answer here is that let's run this. Yes, this works. And this only works from the recent versions of the JDK. I'm using JDK 15. If you use older versions of JDK, this construct did not work, which means the reference has to be initialized inside the try argument, right? Just like this or the other one. This reference did not exist before going into the try argument. But in the most recent version of the JDK, they actually relaxed this. But then the question is, okay, if this argument, this reference exists before the try, it also is available outside the try, right? So, but we know that the try calls the resource on the close on it. So what happens if we call the close on it? So there are two ways that this is basically, this remains up to the developer that how to handle this. You can throw an exception. You usually have a private boolean is closed, and then you initialize it to is close to true in the close method. But then before doing anything in close, you say that if is already closed, you throw an illegal state exception, resource has been closed. This is the recommended way that the we have to call the new. This is the recommended way that the book recommends and encourages, that you always have a private boolean is closed, and then inside the close you first check if the resource has been closed. If not, you go and do the cleanup and use this flag, set it to true, and the next time that is called then you throw an exception, or you do nothing. You either can do this or you can just return, right? One of these two. Now obviously exception is a stronger thing, and most of the time you want to throw an exception so that the program terminates, but sometimes you don't want your program to terminate, you just want to just return, do nothing. All right, so this works, but then if I run this, this line is going to throw the exception because the try with resources already closes this resource. So we're going to see the resource has been closed. So try with resources closes that. But the previous implementation that you had to this reference had to be initialized right inside the try argument was better, in the sense that you knew that it's not the scope is limited, so you knew that this resource is never going to be accessible outside the scope of the try, which was a stronger constraint. But then they decided to relax it and let the developer decide how to handle multiple calls to close, how to handle multiple calls to close method. So in order to see this, the fact that this wasn't available in the earlier version of the JDK, we know that try with resources was introduced in JDK 1.7, and at that time the variable had to be initialized right inside the construct. So I have JDK 8 installed, so in the so I can change or the compatibility level to let's see, let's try to change the runtime. And now as soon as I change the runtime to Java 8, the compatibility level, this gives me a compilation error and says that variable resource not allowed here for source level below 9. So in JDK 7 this try with resources was introduced. In JDK 8 it was still used, and then before JDK 9 you couldn't really initialize this resource before your tribe, like you had to initialize it right inside. And you can imagine that for some classes like buffered reader, it takes a file reader, and file reader takes a file, for example, or file input stream, something like that. And then it just becomes a chain of variables, and sometimes you don't want to initialize them outside, or sometimes you really want the scope of this class to be beyond the scope of the try, and that's why they decided to relax the constraint of the auto-closable references, right? So I'm going to put the runtime back to JDK 15. And this compilation error goes away. All right, so this is more or less the recommended way on dealing with resources. And so let's head back to PowerPoint, and we say that Java libraries include many resources that must be closed manually by invoking a close method, and we use Autocloseable. And classes like file input stream or buffer reader stuff, they typically implement this auto-closable at some level. So what if you writing your own classes, and usually when you're dealing with native resources, usually you have to do native calls. And this is a slide that I have from my other course, which is called Java Native Interface. And this is the general approach that the JDK has adopted for writing the code of the classes that handle native resources. They have a private static native method init IDs that initializes the C++ or native IDs of the Java methods, and then you typically put in init IDs inside the static initializers, and then you initialize and prepare the resource when the object is created. Again, this is the idea of RAII, which is a well-known idea. And then usually in your Java class you have private native methods close 0 and cleanup 0, and these called the C++ code. So the cleanup happens in the native side, not in the Java side, right? Because usually you want to interface with some kernel calls which are written in C++. All the modern operating systems are written in C or C++. So you have to do native calls, and whatever C++ interface you're using to acquire the resource, usually they also provide a function or something for cleanup. So on the Java side you have private native method close 0 and cleanup 0, and these do the stuff in the C++. And then you provide a public method close, which typically comes with the implementing the auto-closable. So this is for manual close and cleanup. And then for safety net, you override the finalize. And again, this is not recommended, but at the moment this is a safety net. If the user, the client of the code, doesn't use your autocloseable class with the try with resources. So notice that it's up to the user of the code to actually put that autocloseable class inside the try with resources. So it's not given. And again, in C++, it's a given that the destructor will be called, but in Java, it's not a given fact that the close method will be called automatically. The user has to put it in try with resources. So some burden is put on the user of the code, but then that's the best we can do at the moment with Java. And then again, finalize is like the safety net that we try to override it and put a call to the close or the native close 0 also inside the finalize, so that at some point, maybe if the object is destroyed, the resource has not been closed, at least we kind of know that eventually the resource will be released by calling the close 0. But yeah, it's better to go deterministic about it instead of relying on the garbage collector. And the good practice is you mark the class with your autocloseable, which is all about item 9, and then the user has to remember to put it in try with resources. And again, in the try with resources, you don't, from JDK 9, you don't need to create that reference to the class or the object inside the try argument. You can put it before that, but and then you kind of figure out how to handle multiple calls to close, right, if it happens. Again, a garbage collector in Java is about memory management, right? And then they try to also add the task for resource management RM using the finalize, which turned out to be a bad decision. And then since JDK 8, I believe this was JDK 7, they added this ARM or automatic resource management through try with resources. And all you have to do as the developer, as the one who writes or develops the library, you have to make sure that the classes that acquire native resources or whatever resources that need to do some cleanup at the end, that class implements autocloseable. And then the try with resources takes care of guaranteeing that the close method will be called at the end of the scope of the try. So that's the guarantee of deterministic call to the close method. Again, it doesn't guarantee that the object will be destroyed, but it guarantees that at least the close method is called, and you know deterministically when that close method is going to be called, right? The other good thing here is that if you implement autocloseable but you forget to call the close and you don't put it in a try with resources, the compiler actually gives you a warning, which is also a nice thing to have. So if I go back to Eclipse, let me close this and then go back to our test class here. We know that this RC class implements autocloseable if I never call the close, and then the compiler warns me. And I think at least this was a nice thing that they added, which says that the value okay, so we are using a let's see, right now it says that this resource is useless because it's never used, so, and it's a local variable. Let's use it, rc dot, I don't know, resource. Let's just do something. Let's say var x equals this. So now we're using this reference, and but then there is a basically so okay, so let me bring this so we have this RC, okay, and then our var x is rc dot resource, for example. Now you see there is a warning on this RC also, and it says resource leak. RC is never closed. And again, this is not memory leak, this is resource leak, and the compiler looks at the type, and when it sees that it implements autocloseable, the compiler says that, okay, I expect to see a call to close at some point on this reference, but it never sees that. This is where the program, the main method, terminates, and that's nice thing that the compiler can warn us about the fact that there could be a possible resource leak because the close method was never called, right? So it's a good thing that the autocloseable, implementing the autocloseable, gives a hint to the compiler to always look out for call to the close method. And if it's never called, then it's a potential resource leak, and the compiler can warn us. It's not a compiler error, but it's a warning, and always take those warnings very seriously. So if you're not familiar with the Java native interface and this PowerPoint, this slide doesn't make any sense to you, I highly recommend you sign up for my very in-depth Java native interface or JNI course. And I have more than 30 hours of in-depth lectures in this course on mixed Java C++ development, and then it's the highest rated course on Udemy for this topic. And then I also recommend you to sign up for a C++ course and refresh your knowledge if you want to do any JNI development, right? Okay, let's head to Eclipse and try to look at one of the core JDK classes that uses this paradigm of providing the native method close 0 and cleanup 0, and then providing a public method close that calls that close 0. So let's head to Eclipse, and that's I believe that's file input stream. So if you look at the file input stream, it has two read methods. One is private native read 0, which is the convention. The private native one ends with a 0, and then a public one just calls the private native one. And the reason that we're doing this because we don't want users to have a weird name. The public method, if it's read 0, it's a weird name, right? It's just read. And then we just under the hood we call this private native method. And another thing is that usually the JDK tries to hide the native methods because it doesn't, otherwise the users might get confused, because native methods don't have any implementation. The implementation is actually on the C++ side, and then you load a dynamic library, and then the JVM knows which method to invoke using the method binding. So JVM has a default method binding scheme for the name of the native methods in the dynamic library in the C++ side. And there are also other methods, skip, which is a public skip, but then there is a counterpart for native one, private native skip 0. And init IDs, as I mentioned, the private static native void init IDs, it initializes the native method IDs for the bindings to the Java calls, right? So this opens0 is native. Its binding is going to be Java underscore package name underscore method name underscore package name underscore class name underscore method name, and these init IDs initializes those, and it also initializes the fields that we need to work with in C++ inside that init IDs. And I'm not going to into details of why we're using the static native void and why we put it in the static initializers. You can just sign up for my JNI course to understand more about this whole native method business. So I just wanted to show you that there is an open 0. There is a basically a skip 0, read 0, and then close. And as you can see, there is a boolean flag that checks the close. And here, if it's already closed, it's not going to throw any exception. It just returns. As I mentioned, you can decide how to handle these multiple calls to a close. Either you return and do nothing, or you can throw an exception and saying that, hey, this was already closed, so there is no point, and closing it again. And then this lock is because of multi-threading. And then file descriptor, it just closes everything. It creates a new closable, and then basically uses an anonymous inner class. So let's go back to our PowerPoint and try to finish this item. So to summarize, closing resources is often overlooked by clients, people who use the library, which means sometimes, or maybe for people who are not familiar with the source code, they don't read the documentation. Sometimes they really forget to call the public close method. That's why marking your class with autocloseable is good, because it gives a warning. With predictably dire performance consequences, because if you never release resources, the operating system at some point doesn't give your program more resources. While many of these resources use finalizers as a safety net, I'm not saying that this is a good practice, and the book also says that, kind of indicates that this is not a good practice to use finalizers as a safety net, because finalizers are already deprecated. Finalizers don't work very well, And again, this whole business of managing resources with finalizers is a bad idea. So garbage collection is all about memory management, not resource management. Try with finally, as we had try with finally, and in the finally you do your cleanup. But then obviously this stuff happens outside your class, right? You don't do any cleanup in your class, which is not good. Since Java 7, we have try with resources. The main problem with try finally was that the close or cleanup operation in finally can also throw exception. To be usable with this try with resources, a resource must implement autocloseable, and it only has one method, which is close. It's a public method, and then in its general API it throws exception, but we usually just comment this out because we are overriding this, so we can change the declaration of whether it throws an exception or not, which consists of a single void returning close method. Note that close method can throw exception, but don't worry about it. When you override it, you can say that it doesn't throw exception. So the caveat is that objects must be created in the try. And again, this is not the case anymore. From JDK 9 onward, you don't have to create the objects right in the try argument, because the scope is not just limited to the try. You can create them before, but then throw them in the try argument, and then the try with resources automatically calls the close method on them, right? So this is not a caveat anymore. They relax this constraint, but I highly recommend that you always create your references right in the try argument. Otherwise, there's a chance that the close method is going to be called multiple times, but sometimes that's not what you want. This restriction has been relaxed in the latest version of the Java, and I believe from JDK 9 this happened. So this was item 9. I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.